All right, hey guys, how you doing? This is Mr. Campbell here. So I'm gonna be absent tomorrow because I have a doctor's appointment that I completely forgot about. So what we're gonna do today is we're gonna do the first 3 pages of notes. Okay, and I have given you an Alex assignment for 3.1. It's not due till Wednesday, and you can always turn it in late, but might as well get a head start on it. And I think that's it. We'll have some in-class practice I'll give you guys as well. The Alex is mostly for practicing at home. All right, so let's go ahead and get started. Some of this will be a review. Some of this will be new. So a what is a characteristic or measure obtained by using the data values from a sample. Keyword. Sample. That is, of course, a statistic. Okay, contrast that with measures obtained from a population. We call it parameter. If for some reason you have a hard time remembering which one's which, just remember that S goes with S and P goes with P. Okay, so we've been working with the mean. This is certainly not the first time you've seen it, but let's make sure we are all hip to the notation and whatnot, okay? So the mean is the sum of the values. Oops. Been a little bit since I've written on this thing. Divided by the total number of values. Okay. The sample mean is denoted by this symbol x bar. We read that as x bar. Okay, so x bar is equal to the sum. If you've never seen that symbol before, it's capital sigma, which just means to sum of all instances of x divided by the number of x's, n. Okay, so let's contrast this with when we have a population mean. Okay, the symbol for this is a Greek letter called mu. It looks like a really fancy U. All right, so mu is almost identically synonymous to the formula for sample mean, sigma, all the instances of x, which we assume to be very many. Instead of using lowercase n, we're going to use a capital N for the size of the population. Okay. So when we calculate these, they are essentially the same. What you need to do is either use Google Sheets, probably what I would do since you're already on your computer. You could use your calculator, which is fine. Probably maybe a little quicker, I don't know, depending on the person. Or you can do it with, paper and pencil. That's fine too. It's up to you. Okay. So however you'd like to do it, you should. Well, I almost don't want to give you the answer for this. But what we'll do is we'll sum all these together. All right. If I had this Google Sheets open on my iPad, I might be able to show it to you. But for ease, let's assume you did one of these. Okay. The calculator, what you do is you create a spreadsheet. Okay. And then you would enter this data in that spreadsheet and then go to OneVarstats. I'm pretty sure there's a tutorial on this on our Canvas page. Okay? But you should get x bar is equal to the sum, 578, over 9, which is 64.2. Okay? N here was, of course, 9. All right? We're asked to find the mean here as well. Okay, when you add up all the x's, you should get 1321 rather. And we have, looks like 5. So gives me $264.2. Okay, so the mean for group data is a little bit more complicated. Okay? We're going to have to use something called the midpoint of each class. So if we do not have individual data values, but rather a frequency distribution of data, which happens often, we can still approximate the mean. Typically, it's pretty darn close to the actual mean. So we're going to find the midpoint of each class. Okay? This is how you do it. You're going to multiply the frequency and the midpoint for each class. Then you're going to sum. We're going to put that number in the last column. And then we're going to divide the sum by the sum of the total frequency. Okay? The formula is given like this. F for frequency, x sub n is the midpoint, and dividing by n. So using a table is definitely going to make this a whole lot easier. Let's work on this one together. Okay? The frequency distribution shows the salaries in millions for a specific year of the top 25 CEOs in the United States. Find the mean. So the midpoint, or x sub m, okay, how would we find that? Well, it's essentially the average of these two. A lot of times we can do this in our heads. Sometimes we will have to, actually find the average. However you want to go about doing it, it's up to you. But right in the middle there will be 18. Okay? Likewise, 25.5 plus 45.5, that'd be what? 46. 46 divided by 2 is 23. Okay? Do the same thing for the next one here. 25.5 plus 3.5, that's what? 56. 56 divided by 2 is 28, so on and so forth. Okay, so what we're going to do here is write in that frequency times x sub m. So it would here be 13 times 18, which is 234. 6 times 23, which is 138. 4 times 28, which is 112. 1 times 33, which is 33, duh. And 1 times 38, which is 38. Okay, we're going to sum these together. That turns out nice. Okay. And then x bar is 555 divided by n, right? So we're going to add this up. 25. So divide this by 25. And we're going to get our answer of 22.2. Oh, look at that. All right, last page of notes, and you can start working on your Alex, okay? This is going to take some time. We're going to spend a lot of time working on this. We're going to use Google Sheets a lot, and so you'll get better with it. What's the median? We explained this in class a little bit, talked about it, but we're going to say the median is the midpoint of the data array. When people say the word array, they really just mean a organizational structure. In this case, we put them in order from least to greatest, left to right. We're going to use the symbol MD. Let's see if we can stick with that. Okay, if there are two midpoints, we will find their average, or find their... Okay. All right, so the first step is to put it into an array, least to greatest, left to right. That's 17.6. 108.2. 159.8, and 222.6. Okay, so clearly this is my midpoint, and then that's the median. All right, I'll leave you guys to do the second one. Remember, if there are two midpoints, you will find the mean, and that will be the median. Even though it doesn't occur in the data set, that will be the median. Okay, of course, the mode is the value which occurs the most often. Okay, keep in mind, there can be, multiple modes. There can be multiple modes. Or there can be none in any data set. If the data set only has one mode, it's said to be, unimodal. If it has two, then we call it bimodal. Prefix bi means two, like bicycle has two wheels. If the data set has more than two values that occur at the greatest frequency, we simply just call it multimodal. And I should say that, they don't have to be exact. If you have like 250 for one frequency and like 253 for a second frequency, they may still call it bimodal or multimodal. Sometimes these are approximations because you're dealing with samples, which are, of course, approximations themselves of populations. All right, this is our last little one here. Last little example, and we'll leave it here today. We'll pick up on next pages when I'm in class on Tuesday. So I see 277s. Anything else repeated here? No? So 77 is our mode. And there's no fancy symbol for that one. We'll make sure that you're tight with the Google Sheets. We'll do some examples of this stuff in class, okay? I think I have a tutorial I might put up there for that as well. All right, so what you're going to do is you're going to hit these 3 pages of notes, and you're going to attempt the ALEKS 3.1 assignment. All right, guys, have a good day.